Okay, Assalamu alaikum warahmatullahi wabarakatuh. I need to solve some questions from previous exams. Evaluate the following integral. Evaluate the following integral. This one on the last semester exam. Okay. How to solve this kind of integration? 4 over x plus 1 square root 3x squared plus 6x plus 10. So we have to complete the square. Okay, when I see this kind of integration, here is a constant. Here I have a quadratic equation. So the first thing I need to think is using the formulas. Okay, using the formulas. Okay. Before I start, I know this will be the formula either for sec inverse or cosec inverse. Why? Because I have outside the square root, I have a multiplication of x. So this is either the cosec inverse or sec inverse, but I need to arrange my integration first. The first important thing, the quadratic equation here should not having any x. So this x should be cancelled. The only way to cancel this one using completing the square. So I have to complete the square here. So x squared equal to 3x squared plus 6x plus 10. A is equal to 3. B is equal to 6. C is equal to 10. Now to complete the square, evaluate b square over 4a. B square is 36. 4 times 3. 4a is 3. So 36 over 12, which is 3. So what I need to do, I need to add plus 3 minus 3. 3x squared plus 6x plus 10 plus 3 minus 3. Plus 3 minus 3 to complete the square. Plus 3 minus 3. Okay, now the full square is the term having x and 3. 3x squared plus 6x plus 3. Okay, the remaining 10 minus 3 is my plus 7. 10 minus 3 is, which is plus 7. So the complete square is the two terms with x and the number that I add. Now this one, you have to take 3 outside first. Okay, the remaining is x squared plus 2x plus 1 plus 7. Take 3 outside. Now you can complete the square. X squared plus 2x plus 1 is 3x plus 1 square plus 7. Again, what I did first step, I have to complete the square. To use the formula, I have to cancel this x first. So you have to complete the square. A is 3, B is 6, C equal to 10. To complete the square, you have to calculate this value, b squared over 4a. This value here, 36, b squared over 4 times 3, which is the 3. So you have to add 3 minus 3. Now, if you add 3, these terms, including x and the number that I add, which is 3, are a full square. Okay, the remaining numbers plus 10 minus 3 is plus 7. Plus 7. Now here, before completing the square, you need to take 3 outside. Make x squared is 1. So x squared plus 2x plus 1. So this is a complete square equal. The square root of x squared is x. Square root of 1 is 1. The sign here is positive, following the sign of p, following plus 2x. X plus 1 square plus 7. So this is the new, or this is the completing the square. So here in the integration, this is equal to 4 over x plus 1 square root 3 x plus 1 square plus 7 dx. What we did, we replaced this one, but by the completing the square. 3x plus 1 square plus 7. So this is now my new integration. Okay, now the second step, to use the formula, all this part, because any formula, we cannot multiply the number square by 3, by any number. So all this part have to be replaced by t square. All this part have to be replaced by t square. So I have to take t equals square root of 3x plus 1. Then dt is square root of 3 dx. Square root of 3 dx. So we have integration. 4 is a constant outside. Okay. Dx dt over square root of 3. Dt over square root of 3. X plus 1 here is t over square root of 3. Three x plus 1 square, all this one is t square. Plus 7. T square plus 7. So now 1 over square root of 3 is cancelled with 1 over square root of 3. So 4 integration dt over t square root t square plus 7. T square plus 7. Now you can apply the formulas. Now it is ready to apply the formula. So the first step, I complete the square. Why? To cancel x from the quadratic equation here. Now 3x squared plus 6x plus 10 is replaced by this quadratic equation. Now I have to change my integration from x to any other variable, for example, t. Okay, how to choose t? I need to replace all this part by t squared. So t should be square root of 3x plus 1. Now this is my substitution. Find the derivative. Then dt equals square root of 3 dx. So dx here is replaced by dt over square root of 3. Okay, x plus 1 from here is replaced by t over square root of 3. Square root 3x plus 1 square become t square plus 7. 1 over square root of 3 is cancelled with 1 over square root of 3. Then you have dt over t square root t square plus 7. So this is a formula. Okay, the formulas will given to you in the test. You go back and check which formula can be used. If you check here, you will find that the formula will be the formula of Cauchy inverse. Cauchy inverse. So minus, here a square is 7. Then a is the square root of 7. So here minus 1 over a Cauchy inverse. Sorry, Cauchy, not Cauchy. Cauchy inverse t over square root of 7 plus constant. Plus Cauchy inverse. This is the formula of Cauchy inverse t. This is the formula of Cauchy inverse t. Now we cannot stop here. We have to write back in terms of x. quadratic inverse, we choose t equal square root of 3x plus 1. Plus constant. So this is the, usually in any exam, you will have one question for the formulas, at least one question, if not two. Okay, so you have to be sure that you understand how to use the formulas. So this one for the last year exam. This one is for last year exam. So we need to learn how to apply the formula. Okay, another example, also for the last year exam, but it was for not formula, it was for partial fractions. This one. Evaluate the following integral from -2 to -1. This is the finite integral. 1 over square root 3x. 1 over, sorry, not square root. 1 over 3x plus 1, x minus 1. So here I have polynomial over polynomial. Here we have polynomial over polynomial. The second one already factorized. So no need to factorize the second one. We already factorized it too. You just need to apply the method directly. So here I have to write 1 over 3x plus 1, x minus 1 equal to constant 3x plus 1 plus constant x minus 1. So this is partial fraction, but the second one is already factorized to you. No need to factorize this one. This is a polynomial. No need to multiply again because some students multiply and then come back to factorize. No need. This one is ready. Polynomial over polynomial, and we already factorized this one, the second polynomial. So you just need to write the fraction. How many fractions? I have two factors, so I have two fractions. First fraction over 3x plus 1. Second fraction over x minus 1. Both are linear factors, so here is a constant. A is a constant, P is also a constant. Now we need to find A and B. So I have to write the equation 1 equal, this part, equal to A. Okay, A is over 3x plus 1, so have to multiply by the other factor, x minus 1, plus B. B is over x minus 1, no, so need to multiply by the other factor, 3x plus 1. 3x plus 1. So here A, x minus 1, B, 3x plus 1 equal to 1. To find the value of A and B, x equal to 1. So 1 is equal. When x equal to 1, this part is 0. So 4b. Which means that p is 1 over 4. B is 1 over 4. Okay, what about A? A, we can choose x. Here, minus 1 over 3. You can choose x minus 1 over 3. So 1 is equal. Okay, minus 1 over 3 minus 1 is minus 4 over 3a. Minus 4 over 3. The second part will be 0. If x minus 1 over 3, the second factor will be 0. So from here, a is equal to minus 3 over 4. So this is b and this is a. Now you need to substitute and integrate. So the substitution, 1 over 4 x, a is over x minus 1, right? No, 3x plus 1. A is over 3x plus 1. So a minus 3 over 4 over 3x plus 1 dx plus b integration of 1 over 4 over x minus 1 dx. 1 over 4 over x minus 1 dx. Now these two integration you can integrate. The first one is minus constant will be ln 3x plus 1 divided by 3 plus ln x minus 1. We have 1 over 4 here outside plus constant. Plus constant. Oh, no, not plus constant, sorry. This one from minus 1 to minus, sorry, this is not plus constant. Sorry. Here, cannot plus constant. This one, integration from minus 2 to minus 1. You have to substitute minus 1 first, minus substitution minus 2. Here, substitute minus 1, minus substitution of minus 2. Make x here equal to minus 1, here x equal to minus 2. And find the last value. Here, be careful. If you have the finite integral, you cannot make plus constant. You have to find the exact value of the integration because this is the finite integral. This one is okay because this one is not the finite integral, infinite integral. Okay, another example also from previous test. Okay, this one. Use appropriate substitution to show that this integration equal to this one. This also one of the previous test question. U equal to cosh inverse 1 plus x squared. Now you need to find du dx. Du dx. Okay, the derivative for cosh inverse, because this is a chain rule here, 1 over 1 plus x squared or 1 plus, because here you don't have x. So you have square root, sorry, x squared plus 1 multiplied it should be x squared, but here I don't have x. I have square root 1 plus x squared plus 1 multiplied by the derivative for cosh inverse multiplied by the derivative for, sorry, square root 1 plus x squared. So this one equal to 1 over 2 square root 1 plus x squared 2x. Right, so 2 with 2 can cancel it. So x over square root. Okay, how to find the derivative here? This is chain rule. The derivative for cosh inverse first, 1 over square root x squared plus 1. But you don't have x squared. You have square root plus 1 x squared. So x is replaced by this value, multiplied by the derivative on side. The derivative for 1 plus x squared to the power 1 over 2 is 1 over 2, 1 plus x squared minus 1 over 2. So this is why I write it below. Multiplied by the derivative inside, which is 2x. 2 with 2 is cancelled, so you have x only. But Before continue, I need to arrange this one. 1 over, okay, 1 plus x squared under the square root with the square will cancel each other. So you have 1 plus x squared. I think, let me check again the derivative for cosh inverse to be sure that it is x squared plus 1. Because I'm not sure the derivative for cosh inverse. I'm sorry, cosh inverse u square minus 1, not plus 1. This one minus, sorry. The derivative for cosh inverse minus 1. So here minus 1. Multiplied by x, 1 plus x squared. So 1 with 1 is cancelled. 1 with 1 is cancelled. This is equal to 1 over square root of x squared. Here we will consider it x over 1 plus x squared. 1 plus x squared. One plus x squared. Okay. Then x with x will be cancelled. This one would be cancelled. So you have du is equal one over square root 1 plus x squared dx. X squared dx. Okay, so now we need to integrate cosh inverse this value. Cosh inverse for this value. Now I need to convert my integration. 1 over square root 1 plus x squared dx will be replaced by du. Okay, cosh inverse, this value, the square root 1 plus x squared, all will be replaced by u. So the integration u du, which means that u square over 2 plus constant. Sorry, not the plus constant because this is the finite integral. Sorry. So u square plus 2 have to write in terms of x first. This is cosh inverse. 1 plus x square over 2 from 0 to 1. From 0 to 1. Cosh inverse square root 1 plus x square. U is replaced by its value. Square over 2 from 0 to 1. Okay, substitute now x equal to 1, then x equal to 0. You will have the answers. If you substitute x, because we need to show that it is equal to this part. So substitute x equal to 1 first. So this will be equal to cosh inverse square root of 2 square over 2 minus cosh inverse 1. Cosh inverse 1, when you substitute x equal to 0, cosh inverse 1, which is 0. Which is 0. So this is equal to this part. This is equal to this part. So here you use substitution u cosh inverse this one. You can start by using substitution u equals square root 1 plus x square. You can start by this one, but you need to use substitution twice. If you go for u equals square root 1 plus x squared, also correct, but you will have to use substitution twice. Or you can use one-step substitution by taking cosh inverse. U equal to cosh inverse. So this is the value. Any question? Okay, another example also from brief. Please, in the integration, practice as much as you can. Okay, for each, especially how to use the formula, how to integrate if you have cosh inverse or tangent inverse. Okay, this is another example. Also from previous test. How to solve this one? Integration, check square over square root 5 minus 4 tanh x minus tanh square x. Okay, actually, I will use both methods, substitution and complete the square also, Talal. So we need to start by substitution first, then going for completing the square. I have to use both because this is kind of the formula question. I will take u tanh x first. Then du will be sec square x dx. So this is integration of du over 5 minus 4u minus u square. 5 minus 4u minus u square. Sec square dx is replaced by du. Then du over squared 5 minus 4u minus u square. So now I have to complete the square, but before completing the square, I need to be sure u square is positive, not negative. So here this is equal to the integration du over, take minus outside, so you have u square plus 4u minus 5. Be sure that u square is positive before completing the square. So how to make here u square is negative. So you need to take minus as a common factor outside. So u square minus 4u become plus 4u minus, instead of plus 5 minus 5. Now I will complete the square for this one. U square minus 4u minus 5. So u square plus 4u minus 5. Completing the square, a equal to 1, b equal to 4, c equal to minus 5. So here I have to evaluate b square over 4a. b square over 4a. So b square is 16. 4 times 1, which is 4. 16 over 4 is 4. So it means that you need to add 4 minus 4. Add plus 4 minus 4. So u square plus 4u minus 5 plus 4 minus 4 plus 4 minus 4. Now the completing square is the terms having u plus 4. This is equal u plus 2 square minus 5 minus 4 is minus 9. So u plus 2 square minus 9. U plus 2 square minus 9. Now go back and replace this one by u plus 2 square minus 9. So this is the integration du here minus u plus 2 square minus 9. Minus 9. So I replace the quadratic equation here by u plus 2 square minus 9. Now multiply the negative sign again. Now multiply the negative sign again. So du over 9 minus u plus 2 square. 9 minus u plus 2 square. Okay, now you can apply the formulas because we have a constant here, a quadratic equation under the square root without u. Okay, this one have to be replaced by a variable square. Let it equal to u, t, sorry. Make t u plus 2, then dt is du. So this is equal dt over 9 minus t squared. 9 minus t squared. So now we need to go for the formulas that we usually have in the test and check which formula is suitable to our formula. Which one is suitable for our formula? What we have here is 9 or a square minus x square. A square minus x square, which is sine inverse. Which is sine inverse. So this is equal to sine inverse t over 3. A square is 9. A square is 9. So a is 3. This is indefinite integral, so plus constant. Evaluate this integral. 2x sine inverse x split t or u equal to x square. Then dt 2x dx. So this is will be integration for sine inverse t dt. Any inverse function to integrate sine inverse, cos inverse, cot inverse, cosec inverse, sec inverse, sine inverse, any inverse function used by parts. Take u equal to sine inverse t. Take du equal to dt. dv, sorry. dv equal to dt. Then du is the derivative for sine inverse t. So we need to go back for the formula for sine inverse t and check the derivative for sine inverse t. The derivative of sine inverse t, 1 over 1 minus square root of t. 1 minus t squared. Okay, the derivative, the integration of 1 is t. The integration of 1 is t. So this is equal t sine inverse t minus integration t over 1 minus t squared dt. U multiplied by v minus integration v du. Okay, this one, how to evaluate this part? Okay, substitution. Here also using substitution, but you need to make y, for example, equal 1 minus t squared, then dy minus 2 ddt minus 2 ddt. So you have to replace the integration here by this one. You need to evaluate this integration t over 1 minus t squared dt. It will be equal the integration of square root of y dy minus 1 over 2. Minus 1 over 2. And then you need to integrate. So minus 1 over 2 here. Here the y as a power function, y to the power minus 1 over 2. So the integration y 1 over 2 divided by 1 over 2. So cancel this one, minus square root of y. Minus square root of y. Which means minus square root 1 minus t squared. This part. So integration of sine inverse t will be equal t sine inverse t minus, okay, we have minus from the formula. We have minus from the formula here and another minus from the integration. So become plus 1 minus t squared. 1 minus t squared. But this is the integration of sine inverse t. You have to write back in terms of x. So this one will be equal. T is x squared. So in terms of x, will be x squared sine inverse x squared plus 1 minus x to the power 4. 1 minus x to the power 4. So for this question, we start by substitution. Tx squared dt is 2x dx. So using this substitution, we converted our integration to sine inverse t. To sine inverse t. Sine inverse itself can be used by parts to integrate. T sine inverse, sine and u is sine inverse t, dv is dt. This function, I need to find its derivative. This function, I need to find its integration. Then apply the formula uv minus integration v du. Minus integration v du. So t over square root 1 minus t squared dt, because the second integration here from by parts have to use substitution. After I use substitution, I have this one. I substitute it here. Then I find the integration of sine inverse t. But my integration in x, so t itself have be written again in terms of x. You can choose another substitution by making t sine inverse x squared. Also can. If you make t sine, instead of choosing x squared, you still can make t sine inverse x squared, which means that sine t is equal to x squared, and then find the derivative. Also can. But in all cases, this solution or the sine inverse, you have to use substitution, then by parts. You have to use substitution, then you have to use by parts. In all cases. Okay, the last example for today. Before next class, I have to start by chapter 4. Chapter 4, same integration. Also as well. This one also. Okay. Evaluate this integral. 1 over square root 2x squared minus 4x plus 5. Constant here, you have a quadratic equation here, so this is likely to be formula. So we have to complete the square because my issue is for 4x have to be cancelled. So I have to complete the square. 2x squared minus 4x plus 5. A is 2. b minus 4, c equal to 5. Then p square over 4a, you have to evaluate. Okay, minus 4 square is 16. 4 times 2 is 8. 16 over 8 is 2. 16 over 8 is 2. Now add 2 plus 2. So 2x squared minus 4x plus 5 plus 2 minus 2. Plus 2 minus 2. Now the complete square is the two terms having x, 2x squared minus 4x, and the number we add, which is 2. The remaining 5 minus 2 is 3. So 2x squared minus 4x plus 2. Here, before completing the square, take 2 outside, which means x squared minus 2x plus 1 plus 3. So 2, the square root of x squared is x, square root of 1 is 1, the negative sign here. So x minus 1 squared plus 2. 2 multiplied by x minus 1 squared plus 3. So this is how we complete the square. Now I will go for my equation and replace. This one, my integration here will become 1 over 2x squared minus 4x plus 5 will be replaced by 2x minus 1 squared plus 3. 2x minus 1 squared plus 3 dx. The 2x minus 1 squared plus 3. Now you need to use substitution because I need to arrange. So t is the square root of 2x minus 1. Then dt square root of 2 dx. So the integration now, instead of dx, 1 over square root of 2 dt over t squared plus 3. T squared plus 3. So this one is now formula. This one is now as a formula. If you check the formulas that you have, you need to check both the inverse trigonometric and the inverse hyperbolic to check which one is suitable for you. Here you have x squared plus a squared, which means sine inverse. This is sine inverse. 1 over square root of 2 sine inverse t. A squared is the 3, so a itself square root of 3. Now you need to write back in terms of x. X is square root of 2x minus 1. So this is 1 over square root of 2 sine inverse square root of 2x minus 1 over square root of 3. This is, I think, the finite integral, right? From 1 until 4. This is the finite integral from 1 until 4. So you have to substitute 4 first and find the value. Minus, substitute x equal to 1. Substitute x equal to 1. Okay, any question? If you don't have any question, let me stop